We're going to start looking at some of the components I've already created to accompany the course, and we'll be starting with the homing component, as it's probably the easiest to get started with, but it also shows a lot of considerations that went into the types of function calls and setup that needed to be made for this type of component to work properly. So if you haven't seen this already, you can add a homing component onto any actor as I've done here. It is currently visualized by this sphere radius here. So as soon as you enter that sphere radius with the correct setup, that will start the cube moving towards you. Before I show you how to get that set up, we're going to go through the class and see what it includes and some of the function calls that needed to be made to get this to work properly. Now these are things that I haven't seen covered in many places before, so hopefully this will give you a nice insight of some of the things that you should really be thinking about to do with things like whether certain components, as you'll see in a moment, the homing component also automatically creates the magnetic sphere component, and we need to consider whether that should be cleaned up if the homing component is ever removed from its actor. And I'll be showing you how we can do that. The first thing to mention is, of course, you can check all of the includes and everything that you need here. You have access to all of this code if you wanted to dissect this, reuse it, or take it apart a bit later. But the main things that we have, I've created a T array, taking in the T subclass of the A actor. This allows us to add absolutely any actor that can be in the world to be attracted to them. I've called that one attract actors. So it doesn't need to be just the player. If you wanted to create complete mayhem, you could add things like falling cubes and it would move towards falling cubes or other objects that could potentially attract it in the world. We then have the float, the magnetic sphere radius set to 500 units, just a default, so anything that has been added to the T subclass of should hopefully trigger this component to get the actor, the owning actor, to begin moving towards that attracted actor. And then finally we've got the homing speed, so just a standard variable that we'll need to allow us to set how fast we want this to home in on the other actor. Now again, I will drop these down, but do remember you have access to these if you wanted to copy and paste or just look into the overrides for the on overlap enter and on end overlap. These are just the very standard kind of bindings that we'll be making to the standard overlap events. And then the two things which were very, very important, these are things I hadn't seen anywhere else. It wasn't super clear how to get this set up, so hopefully this is going to provide some useful insight. But we've got two things, which is one, to check when a component is being destroyed, and we can actually do something kind of like on begin play or end play. Components have an understanding or a function set to track when they're about to be destroyed. Before that happens, we can then do something, and we'll see why this is going to be very important on this type of class that we'll be making here. And then in a similar way, there's a post edit change property, which is going to be very handy to visualize things in the constructor without needing to default to setting up sort of copying logic into blueprints. Otherwise, the things that we create in the constructor in our C++ class will not automatically be visualized inside of the editor. And then finally, just some variables below to track whether we have a valid object for our owner, the thing that we're attached to, the locked actor, the thing that we're trying to move towards, whether or not we're in the homing state, and then the magnetic sphere, the U sphere component that we need to create inside of our constructor. Okay, so the first important thing here is we are beginning this by creating a magnetic sphere, and this is again using the create default subobject of the U sphere component. This one we're just calling magnet sphere. And this is important because remember, we're creating this from another scene component rather than an actor class. So what we're doing down here is we're actually setting the setup attachment rather than our self. So remember in the actor example, which was setting up the attachment to be the actor itself, instead we're setting the parent of this component to be the magnetic scene component that we've added in, or the homing scene component. Then just here we have our on component begin and end overlap bindings. So these are just binding to the homing components on overlap enter and on end overlap. So the overlaps that we can get from our sphere component that we've just created. Now this is optional, but of course it's going to be very useful to know that we have the correct collision responses set up. So I've set this to overlap. So we're going to overlap everything, of course. When you have a magnetic sphere that you're looking to check for other actors, you don't want it to block them. Just forcing the relative location to be zeroed out so we don't have any weird offsets when we create the sphere component. And then this is again very important that we're setting the sphere radius to be the magnetic sphere radius that we have full control over in the editor. Finally, of course, we're setting the owner to be get owner. You've seen that before, just so that we can track that. Now for the tick component, this is where we're going to be doing all of our checking to see if we do have something to home in on. If we are homing, whether we have a locked actor, and that we have a valid reference to our owner, because of course we want to avoid trying to move something that we don't have a valid reference to, either as the owner or our locked actor that we're trying to get towards. This is very simple though, we're just using a vinterp2. We're going to get the components location. We can do that because we're in a scene component, and then we're lerping towards the locked actor's location using the delta time and our homing speed. This of course is drawing a debug sphere, so if you wanted to get rid of that you can just comment this out, but this is again very handy during gameplay to just double check that the overlap is being triggered when you walk into it or when you put something into the magnetic sphere radius. Again, I'll just drop this down in case you wanted to see that. But this is, again, of course, completely optional and just something that is useful for the course so that we can see what's going on. The on overlap enter and on overlap end functions are very, very similar. We're just checking whether we have the certain actors. So on enter, we're checking if the attract actors, the array that we set up, contains the thing that we've just overlapped or has just overlapped the component. If it does, we're going to set that to be the current locked actor and set it to be homing. And then kind of the same, but I guess the exact opposite, is when that tracked actor is leaving the radius, then we're going to set the homing to false and set the locked actor back to null pointer. So this means this is just helping us control what's going on here. So if any of those are false, then of course we're going to stop homing, so we shouldn't have any issues with those. Now again, these are the very important bits, the part I really wanted to highlight here. And what I want you to do is between the modules, come in and remove or comment out these two options here and see what happens when these are not included. And I'll do that in the video, but of course it's super handy to get an idea of this firsthand because without these, it's actually very, very hard to work with this type of component. So in order, the first thing we're doing is we're using the onComponentDestroyed function. Of course, like I said, this is a standard component function that you can find, so we need to call the parent super override first, so the onComponentDestroyed on the parent version of the class. And what I wanted to do, so I'll just uncomment these quickly. When this is destroyed, the important thing is to also remove the magnet sphere that we've just created inside of this scene component. So we're just using the magnet sphere destroy component function call. Now, if you didn't do this, that's probably quite obvious what's going to happen, but basically the magnetic sphere doesn't automatically get taken with the scene component that is its parent. Instead, it just jumps up one level in the hierarchy, and then it is taking the same position in the component hierarchy that the homing component was. So what you're left with is a magnetic sphere, which is essentially not tracing anything for any reason, as it doesn't have the existing parent component to pass that functionality back to, but it's still left in the world. And of course, that can be a little bit annoying, and it also makes it very hard to track it down and get rid of it. In a similar way, in the post edit change property, this is again just a standard call that we need to also include call to the parent function, but this is updating the set sphere radius on the magnetic sphere. So again, updating the built-in function call for our sphere components, and we're setting this constantly to be the magnetic sphere radius. So this is what allows us to track changes made in the editor. Now, if you didn't have this, the changes wouldn't actually be accounted for until you enter something like begin play and you have the call there, or on the event tick. And of course, that's not too useful because remember, in the constructor, we're setting the sphere radius to be whatever we've defaulted this to here. Which means if you were making updates then in the editor, because we've exposed this property in the editor so we can change this on the fly, we wouldn't see those changes until, like I said, you update it somewhere else. So adding this function call in just here allows you to drop in all of the things that you want to see changing in the editor and see those live updates. So if we go back over to the editor, we can see what this is going to look like. So this is what I was just explaining. We can come in, we can change our magnetic sphere radius. So by default, it would have been this. If we just add a new homing component onto something, we can try that very quickly here. So we can see that defaults to 500, which tells us immediately that might be a little bit too large or a little bit too small. And then we can get an idea live in the editor of how big we want this to be. So I'm actually just going to delete that And this shows us the next useful thing is that we can delete the homing component and the sphere goes with it. So just to show you how this works, we're going to go and get this homing component working. So I'll set this back down to something a bit smaller. Homing speed set to 1 should be fine. We're going to add an element to the array and we'll make this the player. So the BP underscore player. And if I press play, and again, I'm also creating this debugging sphere, so we can also see this in the event tick, but of course this is exactly the same size, so it's taking the same variable. So if I increase this, then that debugging sphere is going to be bigger as well. So now what we should expect is when I press play and walk into this sphere, the object here should start tracking us and homing in. So that is working exactly as expected. And as soon as we leave, like I said, those references are being set to null and it will stop tracking something that it doesn't have access to anymore. So that is the homing component, that's how it works. And these are the considerations, like I said, you want to take to make this as workable as possible. Now, because this is inherited, this is the other problem, because the magnet sphere that we've created is inherited, of course. If this is left over because you haven't done that kind of cleanup call, then we can't manually delete this. So I'm just going to go back to the code file and I'll show you what this looks like. Like I said, I think you should definitely go ahead and compile this and make these changes yourself, play around with things and see the kind of results that you get, just so you get that kind of first-hand experience of just how useful and the importance of these kind of implementations can be inside of your project. With that compiled successfully though, we're just going to come back in and the first thing is we can very easily see whether or not the magnetic sphere is going to be updated. So here we go. This is the first problem where I'm scrolling along with the sphere radius. This is being updated, but it's not clear that the actual sphere itself is being changed in size. So we can see that is taking the value separately because that isn't being passed across. So what would happen is if I set this a lot bigger, I need to come in, play, and we can see, of course, that's being updated when we press play only. Likewise, if we add this on to another component, or another actor, sorry, we're going to get that default 500 radius, which again, if that isn't the ideal size, that means that we wouldn't know how close or how big or how small we want to make this until, again, we press play and we update the variable somewhere on begin play or something. So that's the first problem. If we now get rid of this, we can see that I've just deleted the homing component and we're stuck with a magnetic sphere component on this actor. It still follows it around. We still have this connected to this actor when we don't want to. And like I've said, because this is inherited, we now can get rid of it. So you're going to have to come in, delete the actor, and so on. So not the best approach. And like I said, it's something which I haven't seen a lot of information on, but it is a very, very useful habit to really consider as you're going through. Do I also need to tidy up later on if the designer or the user removes this component at some point? Is there going to be anything left over? Is there anything I can add to make things a little bit easier to visualize things? And just to make, again, the process and the whole idea of reusing these components and taking this process is that we can make things a lot more user-friendly, reusable, and kind of quick to get these iterations of the project going. So taking these extra steps in your code is just going to ease that process up again. Like I said, I think that's quite easy to visualize. There are certain things which I think just take that first-hand experience to really appreciate the difference that these two changes can make to the project. So I'm going to compile that back in to make sure that we have that saved and ready to go in future examples. You can play about with that class there. There's definitely a lot more that you can do with the homing class that I've provided here. But that is definitely the main aspects of the class that we've just looked at. So that's how the homing component is implemented. Hopefully this demonstrates the flexibility of being able to expose the class types and the component details to check for not just things related directly to the component you're working on. So the hover component would have been the focus of the class creation there, but also any subcomponents you might be adding into your component because you do have that flexibility to create components within components.